This video is about normal distribution. When a frequency histogram of a continuous data is bell-shaped and symmetric about the mean, we call it a normal distribution. The normal distribution is the most important distribution for a continuous random variable. Here are some examples, like height or weight of a large population, test scores taken by a large population. This is a typical normal distribution graph. You could see this is a bell-shaped. And this point will be mean, median mode. This curve we call normal distribution curve. Try to remember those numbers. This is a probability. We have a mean. Sigma means standard deviation. So your mean minus 1 sigma. The area will be 34.13%. This area will be 13.55%. For this area, it will be 2.15%. Then before mu minus 3 sigma, it will be 0.13%. If a continuous variable x is normally distributed with the mean mu and the standard deviation sigma, we write this. Pay attention to, for this sigma standard deviation, we do square here. For a continuous variable, we can only talk about the probability that an event lies in an interval, and this is true. Let's talk about again this normal distribution curve. From mu minus sigma and mu plus sigma, this is the area. Altogether will be 68.26%. If we add this in, then the area will be 95.44%. If we add this in, then the area will be 99.74%. If possible, try to remember these numbers. Normal distribution properties. A normal distribution is bell-shaped. The highest point on the curve is at the mean of a distribution. The mean, median, and mode of the distribution are the same. The curve is symmetric with respect to its mean. The total area under the curve is equal to 1. Now let's talk about normal distribution problems. Altogether, there are 3 types of questions. Type 1. Find the probability P given this x, mu, and sigma. Mu means mean. Sigma means standard deviation. We got to use this normal CDF then put the lower bound, and then the upper bound. Then you put the mean and a standard deviation. You will get the probability. For second type, we are looking for this small x. You are given probability, mean, and a standard deviation. Remember that you have to make sure this is less than or equal to. Then you go to use the inverse norm, probability, mean, or standard deviation to figure out this x. If we are looking for the mean or standard deviation, we got to use a z distribution or z curve. You still use inverse norm, but for the mean, you will put the 0 and a standard deviation put the 1. You will figure out this z value. For the z value, you got to use this formula to figure out that mean or standard deviation. Let's go to guided practice 1. A speed camera on Peterson Road records the speed of each passing vehicle. The speeds are found to be normally distributed with a mean of 67 km per hour and a standard deviation of 3.4 km per hour. For A, sketch a diagram of this normal distribution and shade the region representing the possibility that the speed of a vehicle is between 60 km per hour and 70 km per hour. When you do the question about normal distribution, focus on those numbers. Which one is mean? Which one is a standard deviation? We already know that normal distribution graph is like bell-shaped, like this. Therefore, we know the mean is 67. For the standard deviation 3.4, I keep adding 3.4 or subtract 3.4 from 67 so that we can draw this bell-shaped graph. This one here. I keep adding 3.4. I will get the 70.4, 73.8, 77.2. The pattern for normal distribution curve will be like this. That's the reason I keep adding this standard deviation so that we can get mean plus 3 sigma and mu minus 3 sigma. That's been very close to the bottom already. Then I just draw the curve now. Yeah, this is the bell-shaped graph. It will be symmetric across this mean. I'm looking for the probability from 60 to 70. I will check where's the 60. 60, it's here. Very close here. And 70, it's here. The probability will be the area, this area, covered by this curve. Therefore, remember that the region shaded, that area represents the possibility. Now let's go to B. We need to figure out the possibility. The speed of this vehicle is more than 60 kilometers per hour. Since I'm looking for the probability, that will be type 1. We got to use that normal CDF, then put the information in to figure out this probability. So we go to distribution, then go to normal CDF, and put the lower one is 60. Upper one, you can put a huge number. Normally, I put the 1 E99. Then the mean is 67. Standard deviation is 3.4. Then put the enter. You will get this. That's a 0.98 will be the possibility for number 1. For second question, less than 70 kilometers per hour. We still go to distribution normal CDF. This time we put the lower one is negative 1 E99 and the upper one that's 70. The mean and the standard deviation won't change. Then the answer will be 0.81. For third question, between 60 and 70, you will put the lower 60, upper 70. Then these two won't change. Your answer will be 0.79. Let's go to guided practice 2. Suppose X is normally distributed with a mean of 37 and a standard deviation is 7. Use technology to find the probability of X greater than 40. Since this is a probability problem, you got to use normal CDF. And we will put the lower one is 40. Upper one is 1 times 10 to the 99th power. We will put mean 37, standard deviation is 7. Then put enter, and you will get 0.33. For B, hence find the probability this X greater than or equal to 37, less than or equal to 40 without technology. Without technology, you have to sketch that graph first. So I sketched this graph already. I label this is your mean plus 3 sigma. Here's mu minus 3 sigma. We already know this area is 0.33. But I'm looking for this area. As we know, this is a symmetric curve, which means when probability this X greater than 37, that equals 0.5. Half, that is 0.5. Therefore, for this probability X between 37 and 40, it's equals 0.5 minus probability X greater than 40. So 0.5 minus 0.33. You will get, the answer will be 0.17. So it's a critical, you know how to draw this normal distribution curve. And you know the meaning of probability. How to express the probability. You have to shade the proper region. Let's go to guided practice 3. The mass of a certain type of chilling cork cup follows a normal distribution with a mean of 400 grams and a standard deviation of 50 grams. A farmer labels one of these corn cups as a premium if its mass is greater than a gram. 25% of these corn cups are labeled as a premium. Find the value of A, which means I have a probability this X greater than A equals 0.25. I'm looking for this A. If you are looking for this X value, you have to use inverse norm. So for the calculator distribution, you go to inverse norm. But be careful. You have to make sure this symbol is less than, not greater than. How we turn into less than? As we know, the total probability equals 1. Therefore, this probability less than or equal to A will be 1 minus 0.25 equals 0.75. Therefore, you need to put this 0.75 to the area. Area, basically, that's a probability. Then the mean is 400, standard deviation is 50. Your answer will be 433.72. So A equals 433.72. When you are dealing with the inverse norm, this kind of problem, this is the key. Make sure your probability you got is less than or equal to this specific value. For B, estimate the interquartile range of the distribution. Interquartile, that means this 3 minus first quartile. That's the range. We assume the third quartile equals B, and the first quartile equals C. Therefore, we know the probability this X less than or equal to B equals 0.75. And this X less than or equal to C will be 0.25. For this 0.75, we already get B equals to A equals 433.72. Then you put this into calculator like this. You will get this C equals 366.28. Then you do subtraction. That's the interquartile range. So this not range, it will be interquartile range. That's 67.44. Or you can use the property of the first quartile and then the third quartile. According to this normal distribution curve, it's symmetric. Therefore, since this is the 433.72, this is the third quartile. We do subtraction, 33.72. Then we do the subtraction here. You will get 33.72. This will be the third quartile, and this is the first quartile. Then we do subtraction. We just do 33.72, add 33.72. That will be 67.44. For guided practice 4, for A, it's pretty easy. We just put all this number in, get the answer. For B, since x greater than or equal to A, you have to put into calculator that is 1 minus, so that we can form this less than or equal to A. It will be 1 minus 0.592. Then your answer will be this. Now let's go to C. Probability of x greater than 23 minus A less than 23 plus A, that equals 0.427. We're looking for this A. First of all, we sketch this normal distribution curve. Suppose this is 23 minus A, and it will be 23 plus A here. Then we draw this line, get the area. This area will be 0.427. Then I'm looking for this area. This area will be 0.427 divided by 2. That is 0.2135. Since for your calculator, we only recognize that x less than 23 minus A. Therefore, for probability x less than 23 minus A, this will be here. This is the one. You will get 0.5 minus 0.2135 to find this probability. Because, you know, this normal distribution curve is symmetric across this mean, 23. So when probability x less than 23, that's equals to 0.5. Then you subtract the probability between 23 minus A and 23, then you will get the x less than 23 minus A, that probability. After you put it into a calculator, you will get the 20.18. That is 23 minus A equals 20.18. Therefore, A equals 23 minus 20.18. You will get the 2.82. Now let's go to guided practice 5. The weekly income of a bakery is normally distributed with a mean of 6,100. If 85% of the time the weekly income exceeds 60, 100. What's the standard deviation? Since we are looking for standard deviation, you have to use that z-curve or z-distribution. According to this given information, we know the probability x greater than 60, 100. That is 0.85. While you put into this area the value, you have to make sure the probability is less than 60, 100. Therefore, we do 1 minus 0.85. We got 0.15. That's the reason we put the 0.15 here. For the z-curve, remember the mean is 0. Standard deviation is 1. You will get this value, we call this is a z. Then we plug into this formula. We know this is a mean, 6100. This x will be 6000. And a z we already got negative 1.03. So we plug in negative 1.03 equals 6000 minus 6100 over this standard deviation. We do cross multiply. 6000 minus 6100, that is negative 100. So for sigma equals, this is negative 100 over negative 1.03. Your answer will be 97.09. Now let's go to guided practice 6. The arrival times of buses at a depot are normally distributed with standard deviation 5 minutes. If 10% of the buses arrive before 3:55 p.m., find the mean arrival time of buses at the depot. According to this information, we know that this x less than 3.55, that's equal to 10%, which means 0.1. Since this one is less than, so we put in 0.1 into this area when we use the inverse norm. And then still z curve, because we are looking for mean. When you're looking for mean or standard deviation, use a z curve, 0, 1. Then this is a z value. We plug in here. So we get negative 1.28 equals. This x will be 3.55. And minus mean over standard deviation is 5. Still, we got to use cross multiply. And you will get 3.55 minus mu equals this to multiply. Then this mu, you will get 3.55 at 6.4. That's mu equals 9.95.